Okay guys, so we continue with the topic of graphs of trigonometric functions, sine and cosine, but now we are going to see what happens when I have a reflection over the x-axis. In this case, if you notice in the example, I have y is equal to minus 2 sine of x plus 2 pi plus 3. If you notice, the coefficient is now negative. So this means that I'm going to be having a reflection over the x-axis. From where? From the original graph of the sine function. This is going to have a reflection. So now instead of the graph going up and then down and then up again, the graph will go down, up, and then down again. It will be reflected over x. It will be reversed or reverted over the x-axis. So let's begin with this example. Let me just gather my things. Okay, we're going to begin with the example. So in this case, my amplitude, -2. The amplitude is -2, absolute value 2. Remember that I count 2 units up and 2 units down from the average y value. The graph is going to be shifted 3 units up due to this number that is adding to the whole function, and the graph is going to be shifted to the left due to this positive sign of the 2 pi. So my amplitude is 2. My b, since there's no number in front of the x, the coefficient of the x is 1, so that means that my b is 1. So for my period, then I will have to do 2 pi over 1, which is equal to 2 pi. My period in this case is 2 pi. Now for the endpoints, the x values of the endpoints, bx plus c is equal to 0. So remember, I take this value directly from the equation, x plus 2 pi is equal to 0, and solve for x. So I will begin at negative 2 pi, and for the other endpoint, bx plus c is equal to 2 pi, solve for x. Remember that I take this directly from the equation without changing the signs. So the plus 2 pi that is here passes subtracting. X is equal to 2 pi minus 2 pi, that is 0. So in the coordinate is minus 2 pi comma something and 0 comma something. In my coordinate plane, this means that my graph is going to be going from negative 2 pi to 0, meaning my extension is 2 pi's, which is exactly what my period is stating. So my extension is of 2 pi's. Okay, the graph, they were telling me that it is shifted 3 units up. So that means that my average y value is, of the original one, remember that it's at the x-axis, it is going to be shifted 3 units up. So the average y value, instead of being exactly at the x-axis, is going to move 3 units up. So it's 1, 2, 3. So my average y value is now here. That's my average y value at the value of 3 on the y-axis. My endpoints, remember that I'm making a box, so I will enclose that box where the endpoints are. In this case, the y-axis is one of the endpoints or one of the edges of the box. And from there, my amplitude, which we stated that was 2, remember that even if this number is negative, this negative sign is only telling me it's reflected over the x-axis, that the graph is reflected over the x-axis. The amplitude continues to be positive 2 because I consider it as an absolute value. So from the average y value, which in this case was at 3 because the graph got shifted 3 units up due to this number, then I count 2 units above that average y value, which is right there, and 2 units below the average y value, which is right here. And there I have my box. Remember that I have to split my period in 4 equal parts. Half of it is right here. So have the period. In this case, if I were graphing normally without the reflection, the graph would go up into the first quarter, but in this case the graph is going down because it's reflected over the x-axis. So if I was doing the regular graph without the reflection, this would be my first quarter and my third quarter. If I split the graph in 4, the graph would look something like this without the reflection. That would be my graph without the reflection, as the original graph of the sine function goes up and then down. But since the graph is reflected over the x-axis, I follow the exact same procedure, and then the only thing that I have to do is reflect the graph. So instead of having a maximum in the first quarter, it is going to have the minimum in the first quarter. It will still cross the average y value at the middle of the period, and then the highest point will be on the third quarter. And this is how my final graph is going to be looking. The red one is my actual final graph. The reflected graph, I just reverse it over the average y value. That's all that is to it. Okay, so the average y value of this one, y is equal to positive 3 because the graph got shifted 3 units up. The domain goes from negative 2 pi to 0, closed in brackets, and the range goes from positive 1 to positive 5. And my endpoints would now be minus 2 pi, which is this one, comma 3, and 0 at a height of 3. And that's my complete example of a reflected graph over the x-axis. Remember, this sign is only telling, this is the sign or what I have that is telling me that it's reflected over the x-axis. Okay, now try this. Try to do this one and we will go over the answer in a little while. So the answer for the try this example, which was y minus 1 minus 4 cosine of 2x minus 3 pi. Remember that having this negative 1 is telling me that the graph is moving up or down, so the graph is going to move down 1 unit. And it can be written at the beginning or at the end of the function. These two expressions are exactly the same. They mean the same. The minus 1 is at the beginning here and it is at the end, but still it means that the graph is shifted down 1 unit. Then I have a negative coefficient for cosine. That means that my graph is reflected over the average y value. My amplitude is 4. Absolute value of negative 4 is 4. The b, which is a coefficient of the x, is 2. So my period is going to be 2 pi over 2. I cancel the 2's. My period is pi. Since the graph is going 1 unit down, the average y value, which in the original graph is on the x-axis, is y is equal to negative 1. Okay, I get my endpoints. Bx minus c. Remember that this one can also be a plus c. It doesn't matter, plus or minus. And remember that this part, I take it directly from the equation without changing signs. So I solve for x. X is equal to 3 pi over 2. Again, 2x minus 3 pi is equal to 2 pi. I solve for x, and I have that x is equal to 5 pi over 2. So this means that in the coordinate plane, the graph is going from 3 pi over 2 to 5 pi over 2. Okay, so let's analyze the graph that I am getting. I have my endpoints. I didn't put a scale on this, but this would be 3 pi over 2. For the scale, this would be 1 pi over 2, 2 pi's over 2, 3 pi over 2, 4 pi over 2, and 5 pi over 2. Okay? This would be 4 pi over 2. That is equal to 2 pi. Okay? That's how I split my scale. Obviously, this would be 6 pi over 2. 6 pi over 2, that is equal to 3 pi, and so on. Okay? 2 pi over 2, this one is equal to pi. Okay, so that's the scale of my graph. If I would be working with the graph without the negative sign in front of the coefficient, this negative not being there, then the graph of the cosine function will begin in the upper left corner and end in the upper right corner of the box. So the graph without the reflection would be something like this. Sorry for my mess, for the not so nice graph. My graph without the reflection would be the black one, but since it has a reflection over the average y value or over the x-axis, then the graph is going in the opposite direction. So my range is going from negative 5 to positive 3. Why is that? Remember that the graph is shifted 1 unit down. The average y value, here, y is equal to negative 1. It's right here. It is shifted 1 unit down, right there. And my amplitude was of 4. So I count 4 units, 1, 2, 3, 4 above the average y value, and 1, 2, 3, and 4 below the average y value. And this is the y extension of my graph, from negative 5 to positive 3. And then splitting my graph in 4 quarters, and this is the final graph of the reflected equation. And my endpoints would be 3 pi over 2, comma minus 5, and 5 pi over 2, comma minus 5, which are these endpoints in the graph. Okay, and the maximum happens at 2 pi. 2 pi, comma 3 in y. Okay.